Hello everyone, welcome back in Skolarhive. So this is the 8th lecture of our basic algebra series in which we are discussing the identities. So I already uploaded lecture number 6 and 7th based on identities. So this 8th lecture is going to be the part for that in which I'm going to discuss the problems based on the identities that I have discussed in lecture number 7. As well as I'll discuss some more derived result in this video which is going to help you in solving some of the typical questions in the polynomial. So let me start with some basic question. Suppose we have given 5x plus 3y is equal to 7, x into y is equal to 3, and we need to find the value of 125x cube plus 27y cube. We have given this value of 5x plus 3y, which is 7, and x into y is 3. We need to find the value of 125x cube plus 27y cube. So here we can find that this 125 is a perfect cube, and this 27 is also perfect cube of 3. So what we can do is we can write this number as 5 times of x whole power 3, and this as 3 times of y whole power 3. Now we can find that this is what the cube of 5x and this is cube of 3y. So basically this is sum of the cube of two numbers. So which we can write with the help of identity a cube plus b cube, which equals to a plus b times of a square plus b square minus ab. With the help of that identity, we can write this as 5x plus 3y times 5x square plus 3y minus 5x times of 3y. And the value of 5x 3y is given as 7. So this is 7, and 5x square plus 3y square. This we can write it as the square of the number 5x 3y minus 2 times of the product of this number. So instead of getting this, because we don't have given the value of x square of 5x, we have given the sum of 5x and 3y. So instead of this one, we can write it as 5x plus 3y whole power 2 minus 2 times of 5x 3y, and this is minus 5x 3y. Okay, so basically what I have written, this is the square of 5x 3y square. I wrote it as 5x plus 3y whole square minus 2 times of 5x 3y. Basically this is the identity. A square plus b square is a plus b whole square minus 2ab. This identity I have used over here. So now next we can write this as 5x plus 3y value 7. So square of this is what? 49 minus 2 times 5x 3y minus 1 times 5x 3y means 3 times of 5x 3y. So this is 7 times of 49 minus. Now if you see xy multiple is given as 3. So this is what? 3 times of 3 9, 5 of 45 xy, 45 xy, and xy value is 3. So once we plus the value of xy, we get this as 7 times 49 minus 40 times 5 times of 3. This will give us what? 135. So 7 times 49 minus 135. Right. So once we subtract this, we'll get this as 7 times of 15 minus 9 is 6, and then 12 minus 4 is 8. So minus 86. 7 6 9 42. So negative 602. The value of this is negative 602. So I hope this one is clear. So now we'll move to the next question. If x plus y is equal to 3 and x into y is equal to minus 8, find the value of x cube plus y cube. So we need to find x cube plus y cube value. We have given x plus y value and x minus x into y value. So this is simple that we have used this part itself in the previous question. So let's try to do it by yourself. This is to yourself question. So one more question let me give you for you to practice, or let me just explain this part, and the next question will be for you to do attempt by yourself. So this you can try. If we have given x minus y, x plus y is equal to, let's say, 8, and x into y is equal to minus of 18, then find x cube plus y cube. So this question you have to do by yourself. So let me explain this part. What is given? X plus y is given. We need to find x cube y cube. X into y value also given. So we'll use the identity x cube plus y cube is equal to the sum of the number times. If you remember the derived identity that we have discussed, as if you are writing in general, this is going to give you x square plus y square minus xy. But x square plus y square value is not given. We have to evaluate this once again, right? But if you have remembered this derived result when we discussed, so we have discussed this as x plus y times of, this is x plus y whole square and minus 3 times of xy. This is also one of the derived identity for x cube plus y cube. X cube plus y cube. So now you can find that x plus y value is given. We can plug over here. X plus y value we can plug over here, and x into y value also given. We need to just plug and simplify. So this is what? This is 3, and this is 3 square minus 3 times of minus 8. So 3 times of 9, and this is minus minus plus 24. So 3 times of 33, which is equal to 99. So the value of this is equal to 99. So this is what the use of identity to find the values of this kind of thing when something is given, right? So the command on identity will come with the practice. If you are solving more and more questions, then only you will find that, okay, in some of the places that you can use some of the derived result, which will make the calculation simpler, and that you can save the time. Okay, so find the value of 73 power 3 plus 27 power 3 divided by 73 times of 46 plus 27 square. Find the value of this using identity. This is the first question, and the second question is 125 power 3 plus 75 power 3 divided by 125 times 200 plus 75 square. So evaluate the value using identity. Okay. So basically, if we look into this question, the numerator is the sum of cube of two numbers. Here the first one is 73 cube, second one is 27 cube, and in denominator we have 73 times 46 plus 70 square. So if you are using the identity a cube plus b cube, the numerator will become like this one, 73 plus 27 times of a plus b times a square, means 73 square plus 27 square minus of 73 into 27, and denominator is 73 times of 46 plus 27 square. Okay, now if we look into this number, denominator and this factor of this a cube plus b cube, that is 73 cube plus 27 cube, we find that, okay, 27 square is there. Here's 73 times of 46. Now if you look into this number, this 46, if you see, this is the difference of those 73 and 27. So if we try to write this as a difference of 73 and 27, what we'll find? We'll find that it will give us the term which is exactly same as this factor. So let's try to write this on. So this sum of these two is 100 and this is 73 square plus 27 square minus 73 times of 27. And this one I'm writing this as 73. 46 is nothing but 73 minus of 27 plus 27 square. If we try to expand this denominator, what we'll get? 100 times of 73 square plus 27 square minus 73 times of 27 divided by 73 into 73 is 73 square, and then minus plus minus 73 into 27, and then the last term is plus 27 square. So if we look into this number, numerator and denominator, both are same only. 73 square plus 27 square plus 27 square minus 73 into 27 minus 73 into 27. So we can cancel both of this. So the result of this is equal to 100. Okay, so this kind of question is just to practice to understand how we can use the identities, not only in just the verifying or simplifying the polynomial, but in some of the calculation like this, uh, we can use the identities to make it simpler. Only just this explanation part I just have done to just explain it. Otherwise, once you look into the question, you can easily figure out that what exactly the things that are going to be cancelled. So that will come with the practice. If you see the second question is also something like similar to that, right? So here 125 cube plus 75 power 3, right? So if we try to find this value, whether we'll be able to find the values with the help of identity or not, we need to check that. So basically, if we look into this number, so let me just change this. This instead of plus we have minus. We have minus over here. Okay. So now we have to find the value of 125 power 3 minus 75 power 3. And in the denominator we have 125 times of 200 plus 75 square. So if you look into this, this is a cube minus b cube form. So it will give us a minus b times of a square plus b square plus ab. Right. So the denominator is, I think, the second part of this like a q minus b q factor. So basically this, if you see this number 200, which is the sum of 125 and 75, right? So we can write this as 125 minus 75, and this will become what? 125 square plus 75 square and plus 125 into 75, right? And the denominator is 125 times 200. We can write it as 125 plus 75, and this is 75 square. Once we expand this, we'll get it as 125 minus 75 is 50, and this is 125 square plus 75 square plus 125 times of 75 divided by 125 into 125 is 125 square plus 125 times 75, 125 times 75 plus 75 square. So this term and this term both are same, so got cancelled. So the value of this is equal to 50. Okay, so I hope this is clear. So I'll give two questions based on the same for you to do it by yourself. Do yourself. 125 square, 25q, 125q plus 75 square, 25q divided by 125 times of 50 plus 75 square. So do yourself, what is the value of this by using the identity? Solve by using identity. Solve by using identity. So second question, this is the first question. Then second question is, we have given over here 80q minus of 20q, 80q minus 20q, and divide by, let's say I'm writing it as 80 times of 100 plus 20 square. Suppose we have given x is equal to 2 to the power 1 by 3 minus 2 to the power minus 1 by 3, and we need to find the value of 2x plus 6x. We need to find the value of 2x plus 6x. So how we can solve this kind of question? So what we'll do, we have to look into the power of this, which is a fraction, right? So we try to make it free from the fraction. So how we can do that? So we have given x is 2 power 1 by 3 minus 2 to the power minus 1 by 3. So if we are taking cube on both sides, what will come? If we take cube on both sides, so x cube is equal to cube of this one, right? Right. So now with the help of this cubic on both sides, the right side we can use the a minus e whole cube formula. That will give us what a cube means: 2 power 1 by 3 power 3 minus of 2 to the power minus 1 by 3 to the power of 3, and minus what? Minus 3 times of 2 power 1 by 3 times of 2 to the power minus 1 by 3, 3ab times of a plus b means 3 to power 2 to power 1 by 3 minus 2 to power minus 1 by 3. So this way we got left side as x cube and right side as this value, and this is nothing but simply 2 power 1 by 3 to power 3 is nothing but 2, and this is 3 got cancelled. When we multiply 1 by 3 into 3, that will give us minus 1 over here. So this is 2 to the power minus 1, and then this is 3 base same, power will be added, so plus 1 by 3 minus 1 by 3 is 0. So here 2 to the power 0, and this value is nothing but x, right? So this is x. So x cube is equal to 2 minus 2 power minus 1 minus 2 times of 2 power 0 into x. 2 power 0 is 1, so this term is nothing but 3x minus 2 to the power minus 1. By reciprocal law, we can write it as 1 by 2, and this is 2. So we just need to simplify this one. So once we simplify the left side, right side, denominator is 2, 1 and 1, so LCM is 2. That will give us 4 minus 1 and minus 6x, right? So basically this is 4 minus 1 is 3 minus 6x by 2 is equal to x cube. So by cross multiplication, what we'll get? We'll get 2x cube is equal to 3 minus 6x. So by transposition, 6x will go to the left. 2x cube plus 6x is equal to 3. So the value of 2x cube plus 6x is nothing but 3. So these all questions is just to practice to like use the appropriate identities and the all this kind of simplification. Okay, so based on this, let's take one example and that you need to just solve. Now do by yourself. If x is equal to 5 to power 1 by 3 plus 5 to power minus 1 by 3, then find the value of 5x cube minus 15x. Okay, 5x cube minus 15x. Okay, so now we are going to learn some of the very important derived result, which is going to help you in solving a lot of questions in Olympiad. So suppose we have given x plus 1 by x is equal to a, then we need to find x square plus 1 by x square, which already I discussed in the first lecture of this identity, which is the lecture number 6 in the polynomial series. Then second one is x cube minus x square minus 1 by x square. Third one is x cube plus 1 by x cube. Fourth one, x cube minus 1 by x cube. Fifth one, x4 plus 1 by x4. Then x4 minus 1 by x4. then x5 plus 1 by x5, then x5 minus 1 by x5. Ninth one is x6 plus x1 by x6. Tenth result is x6 minus 1 by x6. Then 11th one is x7 plus 1 by x7. 12th one is x7 minus 1 by x7. Okay, so for this question, we will try to derive the result for all of these things when we have only given x plus 1 by x is a, and we are looking for these all values. Then we'll discuss some more higher power as well. First, we'll try to understand how we are going to come up with the power 7, power 5, power 6. So we'll simply use all the non-identities that we have till now covered. Okay, so let me just start with the first one, which is pretty much easier. We want x square plus 1 by x square. We have given this one. So basically, if you are squaring this, it will come x square plus 1 by x square plus 2 times of x plus 1 by x. Or it will come x square plus 1 by x square plus 2 times of x into 1 by x. So x 1 by x is going to be cancelled. So this will become what? X square plus 1 by x square plus 2 is equal to a square. If we are squaring both sides of this equation, we'll get this one, right? So from there, we can say x square plus 1 by x square is equal to what? A square minus 2. This is the first result done, right? Now, we want the derivation for x square minus 1 by x square. We have only given x plus 1 by x, right? So how we can find this? So basically this is nothing but we can write it as x minus 1 by x times of x plus 1 by x. And we have given x plus 1 by x value as a. So this is a times of x minus 1 by x. We need to find the value of x minus 1 by x. If we are able to find the value of x minus 1 by x, then we are done. So over here we can find x minus 1 by x value with the help of this one only. So what I can do, over here this is x square plus 1 by x square. If I am subtracting 2 both sides, then the left side will become x square plus 1 by x square minus 2. It means this is nothing but x minus 1 by x whole square. So basically what I am doing is, in this result I am subtracting 2 on the other side. So x square plus 1 by x square minus 2. So this is a square minus 2 minus 2. So this left side becomes x minus 1 by x whole square, which is equal to a square minus 4. So we want x minus 1 by x. So x minus 1 by x is equal to plus minus root of a square minus 4. So this value, if we are plugging over here, then we'll get the result. A times of plus minus this means we can write it as plus minus a times of root a square minus 4. Right. So this one done, this one done. Now let's see the derivation, the result for x cube plus 1 by x cube. So basically, x plus 1 by x value given, x cube plus 1 by x cube identity we know, x cube plus 1 by x cube is equal to x plus 1 by x times of x square plus 1 by x square minus of x into 1 by x. X into 1 by x means what? This is 1 only, right? You just recall the identity. This I can write it as sum of x plus 1 by x whole square minus 3 times of x into 1 by x, right? So basically this is x plus 1 by x times of x plus 1 by x whole square minus 3 times of x 1 by x, right? So x is got cancelled. So basically this is x plus 1 by x value is given a. So this is a times of a square minus 3. So this way we got the result for x cube plus 1 by x cube. Now we'll look for this result, fourth result. So see, if we are looking for this value x cube minus 1 by x cube, with that identity we'll have x minus 1 by x times of x square plus 1 by x square, right? Plus x times of 1 by x. So for finding this, we need the value of x minus 1 by x, which already we evaluated. X minus 1 by x is what? Plus minus under root a square minus 4. So we can write this fourth result as x cube minus 1 by x cube. Okay, let me just erase this part. Just I'm writing all this result over here. This one we got it as a square minus 2. This one is what? plus minus a times of under root a square minus 4, and this one we got it as a times of a square minus 3, or furthermore you can write this as in an expanded form as this way also, aq minus 3a. This will be the much better way. Okay, so write this as aq minus 3a. Okay, and also x minus 1 by x value we got it. Let me write it as separately. X minus 1 by x is equal to plus minus a square minus 4. We'll use this in further these all values. Now I'll suggest you to pause the video and try to attempt this all. By yourself you try and see where you are coming with the result. Okay, and then you can see how I'm trying to find all of these things in terms of e. So now the fourth one is xq minus 1 by xq. You can write it as x minus 1 by x times of x square plus 1 by x square plus 1. X into 1 by x is 1 only. And this we can write in terms of x plus 1 by x square as x plus 1 by x whole square, then minus 2. Okay, because a plus b whole square minus 2ab is nothing but a square plus b square. This is x minus 1 by x. So this value we evaluate it as plus minus square root a square minus 4. And in this bracket, this is x plus 1 by x value is a. So this is a square minus 2 plus 1 is minus 1. So this is basically plus minus under root. We can write this way, plus minus a square minus 1 times of under root a square minus 4. Okay. Now let's see the fifth one, x power 4 plus 1 by x power 4. X power 4 plus 1 by x power 4. If you look into this, we can think of this as power x power 2 power 2, right? So basically this is x power 2 power 2 plus 1 by x power 2 power 2, right? So I can think of writing this as whole power 2, right? So this is a square, this is b square. So we can think of writing this as a, this is b whole square minus 2ab minus 2 times of x square 1 by x square, right? This x square going to be cancelled, so we left with 2 only. Over here this is x square plus 1 by x square. Again we can write it as x plus 1 by x whole square minus 2. So this is what, x plus 1 by x whole square minus 2 whole power 2 minus 2, right? So this is going to give you a. So basically this is a square minus 2 whole power 2 and minus 2. This is the value of a power 4 plus 1 by x power 4 plus 1 by x power 4, when x plus 1 by x is given as a. Okay. So now next, fourth one. I already have like done this result, this first, second, and the fourth, and one more x to power 8 plus 1 by x to power 8 in the like first identity video. So these all things are, I think, this is the new thing which I have not discussed in the previous video. So let's see what are the results and how we can find those things. So the sixth one, you can find this as x to the power 4 minus 1 by x to the power 4. You can write it as x square plus 1 by x square times of x square minus 1 by x square. Right? Because this is x power 2 to the whole power 2. Because we can write this as x square power 2 minus 1 by x square power 2. Or this is what, whole power 2. So this is a square minus b square. So a square minus b square means a plus b, a minus b. Right? So with that identity, which identity? I'm using this identity. Okay. With the help of this identity, I expanded this one. Now furthermore, you can find this as the second one. Again, the identity is fitted over here. So x minus 1 by x square is x plus 1 by x times of x minus 1 by x, and this is x square plus 1 by x square. We can write it as x plus 1 by x whole square minus 2, and x plus 1 by x value is a. So this is a square minus 2, and this is a, and x minus 1 by x value we found it as plus minus under root a square minus 4. So okay, just I'm writing this as x minus 1 by x, and I'm substituting the value now. So plus minus a times of a square minus 2, and this is the square root of a square minus 4. A square minus 4. Now the seventh one is x to the power 5 plus 1 by x to the power 5. How will we get this result? So first thing we have to understand the how can we think of getting the power 5. Power 5 will come either if we are having power 4 into x power 1, or we can think of x to power 2 into x power 3, right? Because base same power will be added. So we need to think something. This x to power 5 plus 1 by x to power 5 is the product of sum of the non-result over here. So if I'm thinking in that way, we can find this as, let's say if I'm taking x square plus 1 by x square, okay, I want over here x power 5. For this x square to give a power 5, what we need? X power 3, right? And to get this x power 5 from x power 2, we want 1 by x to power 3. So once we multiply both of these things, so we'll find that we'll get x to power 5 plus 1 by x to power 5 in the expansion of both of this, but additionally we'll get two additional terms. See over here, x square into x power 3 is x power 5. But when we multiply x square with 1 by x cube, it will give 1 by x. And similarly, if we multiply 1 by x square plus x to power 3, it will give us what? X. And 1 by x square plus 1 by x power 3 will give 1 by x to power 5. So what additional things are coming? X plus 1 by x, right? So those additional things we have to subtract. X plus 1 by x. Now that's fine, right? Right? Now this is fine. Already we know the value of x minus 1 by x. We know the value of x square plus 1 by x square. We know the value of x cube plus 1 by x cube. Then we can plug in the values of these things, and then we'll get x power 5 plus 1 by x power 5. If questions coming directly from here, means at least x power 5 plus 1 by x power 5 means we need these values. We need these values. Okay, x power 2 plus 1 by x power 2, x power 3 plus 1 by x power 3 values. So already we have learned how we can find those values first, right? Already I have discussed how we can find this value, how we can find this value, right? Now you can easily substitute this value, then you can get the result. Or other way, you can find this as x to the power 4 plus 1 by x to the power 4. If we multiply by x plus 1 by x, what it will come? It will come x to the power 4 into x is x power 5, and 1 by x power 4 into 1 by x is 1 by x to power 5. But when I'm multiplying this x into 1 by x power 4, that will give us 1 by x power 3. And x power 4 multiplied by 1 by x is going to give us x to the power 3. It means that term we need to subtract x to the power 3 plus 1 by x to the power 3. So this way also you can expand this one. But I'll suggest you to go with this, because here x plus 1 by x, x square plus 1 by x square, and x cube plus 1 by x cube you need to find. Anyway, here also you need to find the same thing. Additionally, you need to know about this one. So I'll suggest better to go with this one. Okay. But you need to think. It's not like just, okay, this is only the way. You need to think how we can tackle this kind of things. So now basically, what the value of a square plus x square plus 1 by x square? This is a square minus 2. So a square minus 2. And what value we got for a cube, x cube plus 1 by x cube? A cube minus 3a square. A cube minus 3a. Minus this value is a. So these things we can write. Or we can further multiply this and then simplify also. But I don't think that need to do. You just have to look into the like questions requirement. Whatever be the questions requirement, we need to go in that way. So we can say that x to the power 5 plus 1 by x to the power 5 in terms of a is okay. Very good. Now what about x to the power 5 minus 1 by x to the power 5? So let's try to evaluate that as well. So here I found this value, need to remember. We are going to use this one also somewhere. So what we got it? We got this as plus minus a times of a square minus 2 under root a square minus 4. Okay, now we are trying to evaluate this one, x to the power 5 minus 1 by x to the power 5. So think in the same way that I discussed in the 7th one. So try to pause the video first and think how you can write in terms of a if a value is given x plus 1 by x is a. Or we can evaluate x to the power 5 by minus 1 by x to the power 5 in terms of a. You have to think of how you can write in terms of product or difference of some of the non-factors, some of this result. Right. So I want x to the power 5. Again, it will come either x to the power 2 with x to the power 3 product or x to the power 4 with x to the power 1 product. So what I'm doing is I'm taking this as x square. So here minus is there. This thing need to be need to remember. Okay. What I'm doing is I'm taking minus over here, means x square minus 1 by x square. So to get this plus, power x power 5, x power 2 is there. So we'll take x power 3. Means x square into x power 3 is going to give us x to the power 5. Now here we have minus. So if we are taking minus over here, then this will become minus into minus is plus, but we want over here minus. So we'll keep this plus. Okay, now this 1 by x square, that we need to multiply with what? 1 by x cube, then that will give us the result as 1 by x to the power 5. But when we are multiplying these two, we'll get some additional term that we have to completely eliminate from this. So see, when you are multiplying x square with 1 by x cube, that is going to give us plus 1 by x. And when we multiply 1 by x square with x cube, that will give us minus of x. So we'll get this minus of x. So that minus of x we don't want. So what we'll do? See, what extra term we are getting? Minus x and plus 1 by x. Because this x square into 1 by x cube is what? Here plus plus. So this is plus 1 by x. Here minus, this is plus, right? So plus minus is minus. X cube by x square is x. So this is the additional term we are getting upon the expansion of these two. So, but this is additional, these two are not equal, right? To balance both of this, we need to eliminate this. We need to eliminate this means what? This part we need to eliminate. How it will be eliminated? Means just negative of that we are adding, means over here minus x is there, means this is plus x. Plus 1 by x is means what? Minus 1 by x. So basically we have to add x minus 1 by x in that. Right. So now we got the product of x power, x power 5 minus 1 by x power 5 in terms of these things. Right. So now easily we can write this. Already we have derived this result. Or you can further write this as x minus 1 by x times of x plus 1 by x. Right. And over here, this one also what? X plus 1 by x times of x square plus 1 by x square minus of 1 plus x minus 1 by x. If you don't want to use those, further you can write this, because this can be easily written like this, right? A square minus b square. This one. AQ plus BQ. So A plus B times of A square plus B square minus AB. Minus x into 1 by x is nothing but 1 only. XQ plus XQ into 1 by x is 1 only. Right. Okay, so over here you can find x plus 1 by x. So in this all, x minus 1 by x is common. X minus 1 by x is common. Okay, then x plus 1 by x whole square times of x square plus 1 by x square minus 1, and over here what left? 1. Now you can plug the value of x plus 1 by x and x square plus 1 by x square. So x minus 1 by x is what? Plus minus under root a square minus 4, and this value is a power 2 is a square, and these two are in multiplication, right? So this is a square plus 1 by x square plus 1 by x square is nothing but a square minus 2. Or you can write x plus 1 by x whole square minus 2. So those minus 2 and minus 1 is what? Minus 3. So this is a square minus 3. A square minus 3 plus 1. So this is our result. So I hope now you are understanding how we can use the identities. X power 4 minus 1 by x power 5 minus 1 by x power 5. This is what we can like use our non-information on the identities, what we know. Okay, how we can break it into the non-identities. If we learn this, how we can break the things into a smaller thing which already we know, then you all are good in algebra. Okay, so now we left with 4 more. X power 6 plus 1 by x power 6, and minus also there, power 7 also. So let's see how we can find these things. The ninth one. X to the power 6 plus 1 by x to the power 6. Wow. X power 6. Or it comes either x power 5 multiplied by x power 1, or x power 4 multiplied by x power 2, or x power 3 multiplied by x power 3. Which seems to be easier? This one, right? Right? Or another way also you can do. The better way is that you can write this in terms of identity. You can do this as x power 6. We can write it as x square to the power 3. The same way this one as x square to the power 3. So basically this is x square I'm considering as a, then this is aq and this is bq, right? So this is what x square power 3, and this we can write it as 1 by x square whole power 3. So this is aq, this is bq. So aq bq formula is what? A plus b times of a square plus b square minus ab. So we can write this as x square plus 1 by x square times what? A square. This is x square square. This is a. This is a. This is what? A square of this plus this is b. So square of this minus x square into 1 by x square. X square into 1 by x square. So this is going to be give us 1 only, right? X square got cancelled. Then this is basically 1. Okay. Now what next? What next? This is already known, a square minus 2. We need to further simplify this. We can write this as x square plus 1 by x square, or you can write it as x plus 1 by x whole square minus 2, right? So write down that way only. So this is x plus 1 by x whole square minus 2, and this one is x square power 2, and then this is 1 by x square power 2. So what we can do, if I'm going to add 2 over here and subtract 2, then this will become x square plus 1 by x square whole power 2 it will come, right? So what I'm doing is, see, a square plus b square is what? A plus b whole square minus 2ab. Okay, if I'm using this result, so this is what? This whole thing is a. So a square plus b square. So I can write this as a plus b, means a, this is x square is a, and b is 1 by x square whole square of this minus 2 times of AB. A is this. So multiplication of x square, 1 by x square is 1. So minus 2 minus 1. Right. Now we are done. We are done. So what is the value of x plus 1 by x? A. So this is a square minus 2. A square minus 2. And x square plus 1 by x square. This value only we got. X square plus 1 by x square is this one only. Which value? Whose value is what? A square minus 2. So I can write this as a square minus 2 whole power 2 minus 3. So minus 2 minus 1 is minus 3. So this is the result for x power 6 plus 1 by x power 6 in terms of a when x plus 1 by x is a. So I think these all things are clear. It's just a matter of using the identities and just trying to like resolve the higher power into the product or powers of some small parts. Okay, some parts whose identity is already known. Okay. Now we want the value of x to the power 6 minus 1 by x to the power 6. This also can be done in the same way. Write this as x square to the power 3. Then that will become aq minus pq identity form. So we'll get this as x square power 3 minus 1 by x square whole power 3. So this we can write as x square minus 1 by x square times of x square plus 1 by x square power 2 minus product of these two is nothing but over here minus means this is plus. So x square. Now x to the power 7 plus 1 by x to the power 7. Now think again, x power 7 will come as either x to power 2, x to power 5 product, or x to power 3, x to power 4 product, or x power 6, x power 1 product. So which one we have to go? We can go for any of this, either this, or this. So for finding x to power 6 will be easier, right? We already have seen x to power 6. Finding x to power 6 is easier, right? That we can write as x cube, x square to the power 3. Or we can go with this also. Both are fine. So let me go with the second one. So how I'm going to write this? I'm going to write this as x power 3 plus 1 by x power 3 and then x power 4 plus 1 by x power 4. So once we multiply this part of these things, we'll find that this 2 multiplication will give x power 7 and this 2 multiplication will give 1 by x power 7. But once we multiply this with this one, that will give 1 by x and this 2 multiplication will give x. So x plus 1 by x is coming extra, right? So we want to subtract this one. So subtract x plus 1 by x. Then both will be balanced. Left side and right side will be balanced. Okay. Now this value already given x plus 1 by x is a. And we already found x cube plus 1 by x cube is what? aq minus 3a. This is what? aq minus 3a. And this one is already be evaluated. Or if not, means just we can write it as x square plus 1 by x square whole power 2 minus 2. Right? And this is minus a. So basically this is aq minus 3a and this is what? A square minus 2. X plus 1 by x is a, then this value already we evaluated a square minus 2. So basically this is a square minus 2 whole power 2 minus 2 and minus a. Right. So you can write this way or you can further simplify this as well. A is common over here, so a square minus 3 times of this one, a square minus 2 whole power 2 minus 2 minus a. A is common in both of this, so we can take a common and then we can write it as a square minus 3 times of a square minus 2 whole power 2 minus 2 and then minus 1. Okay. So this is the way we can get the value of x power 7 plus 1 by x power 7 in terms of a when x plus 1 by x is given as a. So this is the last part which is x power 7 minus 1 by x power 7. The same way we'll write x power 3 minus 1 by x power 3. Then x power 4, as here minus taken, we want minus, so we need to keep plus over here, plus 1 by x power 4, right? So once we multiply, we'll get this x power 7 minus 1 by x power 7, but we'll get some additional thing. The additional thing is what? Minus x plus 1 by x. This two multiplication is plus 1 by x, this two is minus x. So this we don't want this, right? So we'll take the subtract, this means we're subtracting minus x plus 1 by x means what? It will come x minus 1 by x. Then this will be balanced, right? This will be balanced. Now x cube minus 1 by x cube means what? X minus 1 by x times of x square plus 1 by x square plus 1, and this value we can write it as x square plus 1 by x square whole power 2 minus 2, right? And this is x minus 1 by x. So in this 2 we can take the x minus 1 by x common, then we'll left with x square plus 1 by x square. Its value is a square minus 2, so a square minus 2 plus 1, and this one is, this is what? A square minus 2 whole square minus 2. Okay, and at last this is taken common, so 1 is left, right? So this 2 in multiplication, okay, this 2. So this is what? The furthermore, a square minus 2 plus 1 is what? Minus 1. So we can write this as x minus 1 by x is what? Plus minus under root a square minus 4 times of a square minus 1 times of a square minus 2 whole square minus 2 and then plus 1. Okay, so this is the way we can write x power 7 minus 1 by x power 7 in terms of a when x plus 1 by x is given a. I hope these all things are clear. So just follow the method that I have discussed. Okay, and then you can derive all of this result by yourself as well. Just understand how we are breaking this. So in the next video, we'll discuss some more very important result in the identities, and that is going to be the last video. So stay tuned and just follow me like in each lectures and just try to solve the questions what I'm giving as a do you by yourself. Okay, so next video is going to be the identity last part, and then after that we'll discuss the factorization. So 3 more videos I'll add in this basic algebra series, and after that I'm going to start the trigonometry as well as parallelly I will start the plane geometry as well. So stay connected and be happy and try to solve more and more